I think we can start now.
Okay, let's start then. Good afternoon, everyone, and welcome to this webinar on road safety, technological solutions from three European Union-funded projects. Before we move on, just a bit of previous information on board this webinar. Please keep in mind this session is being recorded. The recording will be made available to all participants, to all registered participants online after this event. Please use the Q&A box to write your questions. My dear colleague Niklas Schmalholz will fish the questions from the box to ask our speakers. On the program from today, we will be looking at three very interesting European projects: PHOEBE, SOTERIA and V4SAFETY. We will have key people in these three projects sharing what they're doing. And it's very exciting because, as far as I know, these projects are starting. So whatever discussion we have here and input and questions that you may provide, I'm sure that the project members will have them in mind in the development of their projects. My name is Pedro and Gouveia. I'm coordinator for road safety and at POLIS, the leading network of European cities and regions working on transport innovation. For Project PHOEBE, we will have James Bradford and Shana Lucchesi. For SOTERIA, Marina Georgiou and Panagiotis Georgakis. And for V4SAFETY, Olaf and Sane van Giels. And finally, we will wrap up with some social media information by my dear colleague, Niklas Schmalholz. First, before we move on, a short word of, I did something wrong, I'm sorry. Okay, before we move on, I think I'm blocked. Okay, just a few words on as a way of introduction about why safer thinking is necessary to get safer streets. Well, number one, if we look at road fatalities in the European Union from 2003 to 2018, we see that they have plateaued. The numbers from the previous years, as you know, were heavily tainted by the lockdown, 2 years of lockdown, which had very mixed results. And results just published last week by the European Union show a decrease. But in any case, when we look at the past decade, what we see is that several years of decreasing in road fatalities and serious injuries, they have plateaued. This is not the case. This is not the same situation across Europe. What we see is that in some countries in Europe, things are much better. Progress is much faster than in others, such as my own, Portugal, right there on the lower left corner. So the thing is, there are advancements, and it's not by chance. Somebody's getting it right. When we look, for example, at the data from Helsinki or the data from Oslo, what we see is a sustained decrease in road traffic fatalities, and they've reached zero. That's the case for Helsinki, that's the case for Oslo, and that's also been the case for around a decade now for the city of Pontevedra in Galicia, northern Spain. So what are they doing right? We'll talk about that, but also, I can also share with you from my personal experience that, I mean, when you do traffic calming, when we reduce the speeds, we do find substantive reductions in crashes, in fatalities, in the number and in the severity of these crashes. These are some cases where, when I was working in Lisbon, we intervened in some high crash sites, and we observed that reducing the speed severely reduces the crashes. So the point is that today we have the knowledge and the means to eliminate traffic deaths and serious injuries in city streets. The point is for some reason my screen stopped sharing. Give me just a second. The point is that, you know, things aren't going well everywhere. Why? If we have the knowledge and the means. My PowerPoint isn't very friendly today. Sorry for that. Question is, if we would look at the deaths and serious injuries caused by traffic, road danger as a result of a virus, we would quickly understand that the vaccine has been invented. And the real challenge that we face is not looking for new medication, but it's accelerating the production, the distribution, the application of this vaccine, and dealing with people who don't believe in medicine or don't believe in vaccines. Sounds familiar. But this implies a paradigm shift. And when we look at why in previous cases in history, there was a solution at hand and things didn't advance or took a long time to advance, maybe we get to understand why thinking right and why organizations have a role to play. A famous case is Dr. James Lind. He was a medical officer on board the Royal Navy in the early 1700s. When the Royal Navy set sail to cross the world to New Zealand or Australia or China, up to 1/3 of the crew would die on every voyage. 1/3, 1 out of every 3 members of the crew. Dr. James Lind found out, today we know this was caused by scurvy, so the lack of vitamin C that makes your teeth fall out and be open to infections. Dr. James Lind, who was a young medical officer at the time on board one of these ships, he found out that by giving every sailor 2 teaspoons of lime juice every day, he could eradicate a problem that would kill up to 1/3 of the crew. He came back. This was one of the first clinical trials in history. He came back, he published the results, and still it took over 80 years for the Admiralty to implement this procedure as a standard procedure in the whole Royal Navy fleet. Why? A similar case is of Dr. Niklas Schmalholz, a Hungarian-born doctor who practiced medicine in a hospital, in a maternity here in Vienna. Well, if you've been washing your hands for the past 3 years, this was the guy who found out that was important. He found out that if doctors and nurses wash their hands in a chlorine solution between tending to the next patient, they could almost eradicate the deaths of mothers who were dying after giving birth. There was a huge number of infections. Well, he published his results. Do you think his colleagues liked it? Well, they hated him. He ended up leaving the hospital and ended his days in a mental asylum with what probably would call this day a burnout. He was not respected. Why did these discoveries not work or take so much time? The point is that diffusion of innovations is a social process. And as such, it has to deal with the realities and the dynamics, social dynamics inside organizations. We all know that there is a tendency to a resistance to change, a wish that, maybe we can avoid changing anything and things will magically improve. There's also a fear of innovation. If you come and apply a new method, a new tool, if something goes wrong, you're the guilty one. I mean, if things keep going wrong because you're doing the same thing as everybody else, well, nobody's going to point a finger at you. And finally, we also have to understand that often the people who are leading, even at the political level, transport and road safety decisions are not aware of the advances of the science and sometimes go for the easy solutions. And that's one of the reasons we see so many education and advertising campaigns, because people feel they want to do something, although we know that these campaigns have a very small and short-lasting effect. So we have to deal with the way the organization changes. If we assume goals and that the organization is not capable of delivering on those goals, then of course there's a problem. Now, the point here is that waiting for political will, the way we usually talk about political will to deal with road safety, for this reason that I've just stated, is only part of the issue. And we have to understand that politicians, when they are asked to commit their political capital to some sort of goal or new solution, they want to know if the organization stands behind them, if the technical practitioners inside the organization they are leading, what do they think, if they are on to accepting these new methods and tools. And that's a key problem. It goes way beyond political tools. It's about organizational capacity. And there are three different dimensions to have in mind. One of them is resources, obviously the money, but the infrastructure, the equipment, the tools, what have you. The other one is the people, the skills they have, the abilities they have, and obviously if they're open or not to change, which often depends a lot on how change is presented to them. And finally, the processes, which for people like us in the transport sector, this means, are there protocols to deal with different situations? Are there road safety plans? Are there road safety manuals? Is there guidance, etc., etc., etc. Now, throwing tools at people for the reasons we've seen before is not enough. Tools are very important, but we must understand the framework within which these tools will be used. Otherwise, it'll happen like Abraham Maslow said, if people have no tools or have a simple tool, they tend to apply the tool the only way they know. And so bringing in new tools must also bring in a new mindset, a new approach, a new paradigm. Otherwise, people will keep on looking for nails. So changing the way we think about things is critical to changing the way we work. And changing the way we work, obviously, is indispensable to achieve new results in road safety. So we have to keep in mind that it's not only the way we think, it's also the way we talk. Ask any cognitive psychologist or any social psychologist, and they will explain that the words we use shape the way we think. And the way we think shapes the way we look at problems. So it's very important to have this in mind when we discuss vulnerable road users and when we discuss road safety. I remember a long time ago when I started working on pedestrian safety, everybody thought it was the pedestrians' fault. They jump in front of the cars, they cross out of the crosswalks, they cross against the red lights, etc., etc., etc. They also said, well, the young kids, they text, they hear music, they walk slow. Because I had been working for a long time, 10 years already, with people with disabilities, you may ask a person who's looking at a cell phone, may try to educate her to look up at traffic, but you cannot educate a blind person to see. Neither can you educate a deaf person to listen. Neither can you educate an 80-year-old lady to, come on, walk fast across the street. So the point is, the words and these ideas that we use about looking at the vulnerable road users, that's the ones who should, mind and be careful. It's really the wrong approach, because then, and it gets actually to be a dangerous approach, because then we focus on things that have little impact on the safety of people, although we want them. The point is, for example, this is a real case. It was happening very near the place I worked. There was a 16-year-old girl who was crossing the crosswalk on the green for pedestrians with a reflective vest, with a helmet, and she was carrying the bike. She was using the bike lane crossing. What did that help? Because the driver of the car was looking at his cell phone and, of course, smashed and killed her immediately. So the point is, we must understand something that in health and safety has been established for a long time. There's a lot that road safety must learn from scientific and technical advances and philosophical advances in health and safety, which is, this is one of the examples, the hierarchy of controls. Of course, in a factory floor, if you have a dangerous machine, the first thing is, or dangerous chemicals, you see if you can remove them. If you cannot remove them, you see if you can replace them with something less dangerous. If you cannot replace them with something less dangerous, well, you isolate the danger to protect the workers. And then, and only then, is it proper to talk about administrative controls, about using protections, which are necessary and are systematically implemented. But the point is, first, you deal with the source of danger. So when we talk about road safety in urban areas, are we going to put a chip on every pedestrian, chip on every cyclist? Are we going to try to educate each one of all millions of pedestrians and cyclists, which are basically the whole population because everybody walks? Are we going to educate them to overcome their age and their disability? Or are we finally going to focus on the source of danger? And this is not an anti-car speech. It's just a practical health and safety speech. You focus on the source of danger. It's the only and the most effective way of protecting vulnerable road users. Because, again, you can use all the helmets, all the high visibility vests. If the source of danger is not constrained, there's nothing you can do for everybody who is outside of the car. And so may we finally understand that vulnerable comes from the Latin to wound. And maybe the people that are, maybe will finally, with this new approach, stop looking at people who do their everyday life in the streets of our cities as somebody who can be a wound or hurt, and instead look at them first as people. We have to finally, and just the final idea, we have to finally to understand that loads of barriers that come to the promotion of road safety come from the fact that over the past century, our ideas about road safety have been shaped by car advertising. And again, it's not an anti-car speech, it's a basic anthropological fact. And that, of course, influences the way we look at this, the way that, for example, we put road safety against congestion, failing to realize that you can both reduce congestion and increase safety at the same time. Just like, for example, they did in Bilbao, they reduced speed limits all across the city, and things are much better today for everybody. So can we do it? Well, it depends on how we're thinking. I'm going to stop sharing here now, talk a bit too much, and let me invite my dear colleague James Bradford from IRAP to come and present Project PHOEBE. James, are you ready?
Yes, thank you very much, Pedro.
Go ahead.
So yeah, brilliant introduction there. So in this bit, I'll take you through what is Project PHOEBE, what issue we're trying to address, what are we seeing, the issues surrounding it and the connected things, and then moving on to what are we going to do to try and address it and correct it in the future. So very much when we looking around to the road safety situation, we zoomed in on the traffic and use of the urban areas, and recognizing that actually there's a massive amount of change going on here, both in terms of our expectation of urban areas, how we move about them, and how we interact with them. And looking at a lot of the models at the moment for analysing urban areas, and so it's like traffic models and whatnot, we can actually see that a lot of those are very much focused around vehicles, cars and trucks and motorcycles in particular, and don't necessarily take into account these newer forms of transportation that are coming out at the moment. And then likewise, what we also can see is that there isn't the same level of integration with some of the other tools, especially the safety tools that are available at the moment for managing road networks. So the traffic models are providing you something at the very much in the detail level, and that's not then bringing in that very much higher level that we're seeing. So what we're trying to do within the PHOEBE project is look at how can we actually interlink those two levels? How can we use those proven simulation models and actually align them and weave them in amongst with the road safety assessment methods? So pulling out and coming together to actually produce like a dedicated safety module within simulation tools. So that's very much the focus of it. Yeah, a simulation tool, the model that can actually look at both the infrastructure safety, the speed, how people are using the roads, and how that modal shift might come about or might be influenced by other things like the infrastructure. Likewise, looking at the human behavior and how that can be built into the system and utilized to actually influence the other ones. And then finally, using new data sources, so both the traditional ones, but actually new ones as well. So we're seeing a lot of progress that's happening at the moment, both in terms of AI and ML techniques. Likewise, you've got big data sources and stuff like that, and actually exploring those and saying, how can we actually integrate those to harness that much more effectively? So very much with our vision is looking at both the micro level stuff, the individual road users, but then balancing that with the macro and trying to actually get this hybrid between those. So actually we can move the game forwards on those, so we can actually understand what the safety and socioeconomic outcomes would be, both in terms of new forms of transport, so whether that might be scooters or it might be ride sharing or new technologies coming along. So whether that's things like cabs and likewise, or as we're seeing things like behavior and regulation change, how might that actually influence? How do we reflect those, both in terms of the risk to all the different road user groups, especially the vulnerable road ones, as Pedro was highlighting, and also looking at is there any significant game changes that can be put in place? And if so, where should they be put in place? And what kind of returns and benefits would they provide us for the level of investment in them? So taking that stage further, within what we want to do within the PHOEBE project is to actually pull together a framework of how cities could do this. So not necessarily the one solution, but it's actually about how do cities actually structure and progress towards this, recognizing that they might have different safety assessment mechanisms in their cities, or they might be using different traffic simulation models. And so providing them that almost that way through that they can actually start to integrate those and actually prove it and demonstrate it and implement it. So the different objectives that we want to do within the PHOEBE project is to actually demonstrate that framework by actually producing a model that can actually pull those two different elements together, so that both that traffic simulation along with a safety modeling or safety assessment, looking at how the different definitions are used between the different systems, and also across the different systems that are available, and coming up with very consistent definitions of this is how this is going to be referred to within them, so that they can actually start understanding and using that common language between them. We'll look at the current assessment or risk assessment models that are available. So whether that's things like the IRAP star rating or other different tools that are available, and saying how can they be evolved even further to improve their accuracy and their compatibility with the urban areas. We also want to put into their social components into risk assessments, so you can actually understand not just about how the infrastructure is implementing it, but also looking at about human behavior. As you're changing the infrastructure, what does that mean in terms of modal shift? Trying to pick apart some of these ones of understanding that if a road environment feels unsafe, then less people will be using it to walk and cycle around. So what is it that we can be doing? But more importantly, how is that going to ripple onto it? Exploiting those, like I was saying earlier, the big data and the telematics data, running them through AI and machine learning models to actually understand that further and see what kind of further advances can be made, both in terms of modeling that traffic moving around, but also the safety in which it's doing it. And then finally, to actually prove this by actually putting it into some pilot applications. So in terms of pilot applications, we've got 3 different use cases we're focusing on in Athens, Valencia, and West Midlands, looking at them differently, and each of them having slightly different data available to them and different experience with safety risk models, and seeing how we can have this consistent approach to build that framework so that they can actually move forward. So the way in which we're going to do that is to look at those individual locations, look at what data is available, and actually pick specific locations or areas or routes, and that we can actually look at that in a lot more detail. So that's going right down into specific details. From that, we can then actually build up our simulation models to actually understand that environment, how the different users are interacting, the level of safety that is on those networks. From that, we can then take out the evaluations, so whether that's producing dynamic safety scores like dynamic star ratings or similar, so that we can then rerun that and continuously understand how, as the network use changes, or as we put in different scenarios, what the outcome would be within those selected locations. And then finally, taking it out to the much bigger level and saying, well, from these learnings, how could we forecast what's actually going to happen on a wider network? And so that you can then step out to potentially a whole city level or even further to actually forecast how things are going to be changing and evolving in the future. And more importantly, what can we do to actually influence those and make those positive steps towards seeing that risk managed? So within the PHOEBE consortium, we've got 11 partners. We're spanning across 7 different countries. And here you can see that they come from a variety of backgrounds, whether that be from technical universities, from corporate entities or consulting entities, or from NGOs. And so what we have is a very strong partnership between them, all bringing slightly different aspects and working in harmony together. Thank you very much for listening to me. So may I hand back to Pedro?
Yes, my dear colleague, thank you, James. Very interesting. My dear colleague, Niklas, will handle the questions. Niklas, what have you fished from the chat and Q&A box?
Yeah, there's a question from Niels Böhle, I think Dutch or German, I don't know, hopefully I pronounced you correctly. Are you planning on expanding the areas of research, for example, on the behavior side? A lot of the shared space environments will score badly on user experience, but objectively, it is very safe. We also do not see people not use these. We also do not see people not use these areas. So how can you integrate that into your research? So it's about shared space environments. Maybe you can elaborate on this, James, a little bit.
Yes, certainly. That's one area. One of the areas we do want to look at is, are we getting the level of risk right? Where people's perceptions versus actual risk at those locations. Likewise, what is it that we can be doing there to actually make sure that the right level of flow is, or the usage is untapped relative to the demand. So yes.
More questions?
Yeah.
Niklas. We have time to squeeze James a bit more.
There's a question from Deepak Katara. How can we improve work zone safety? I'm not so sure if this is really related to the traffic planning or urban mobility, but maybe yeah, you can elaborate how it can improve safety in general, and what could be the PHOEBE outcomes for that.
Yeah, so I see potentially two ways that you could be using the phrase work zone safety. The more obscure one is where people are generally doing their work in business, so that might be going to the office or whatnot. So certainly PHOEBE will have benefits in that area. Understanding how people are commuting to the office, and also maybe going out at their lunchtimes, but as that vehicle flow and the pedestrians move around. On terms of actual road site work zone safety, there won't be too much into that at this stage within the PHOEBE project, but I think there's a massive scope for actually going to that into the future. So as these traffic models, as we enhance them and improve them, you'll then be able to actually step it further through into understanding what is the impact that potentially a road closure would be having, and how would it be moving different flow around the network. Yeah, in terms of, would it be putting pedestrians into the roadway, or would it mean the bicyclists are taking a different route? So there is real scope for that in the future.
Then I have a question to elaborate a little bit more, so that everyone here in the audience can understand what we actually mean. Some people attending this webinar may not be familiar with the concept of predictive safety assessment. Can you please explain what this means? So I think it's a bit easier, so that everyone gets on board here. Yeah,
this is important. So what we know is ultimately we want to address crashes and reduce their severity when they do happen. The big problem we have with crash data is, one is it's not always accurate. It always lags, and it's a historical representation of what has happened. And what I find especially frustrating with it is not always statistically reliable, so that as you improve your safety on the network, you'll see those crashes become more and more sporadic and don't always follow the pattern, and you need to have longer and longer time horizons to understand that. So what predictive safety is doing is taking that crash data and having analysed it to produce things like crash modification factors and safety performance indicators, to actually say, we understand what's the dynamic happening here and the relationship between different road features and the risk, and projecting that forward. So it's about estimating the risk and being proactive rather than responding to, oh, we've had a crash at this location or a cluster of them, we need to address this site. The big advantage, and where that can step forward, and big advantage of it, is then you can be saying, well, I've got an identical site to that one. It just so happens that there was a local something going on there, but if we address this other site that's identical, actually we'll avoid having crashes there as well as that site where we've got those clusters. So it's using those kind of principles, but on a much bigger scale.
Mm-hmm. Shall we go for one more question, maybe to step to have a step back, a rather broad one, also to get everyone on board here, and to sum up what PHOEBE is doing. What type of benefits can we have in integrating safety into traffic simulation? So maybe this will also, it's a natural bridge towards the other presentations, of course. Yeah, so there are multiple benefits, but the key ones that I'd like to draw to people's attention to is understanding where the risk is on the network, how that risk would dynamically change over time, especially as things like flows of vehicles change through the day. Likewise, as speed change, being able to actually understand how that's happening and how that's actually impacting people's use of the road network. And their safety as they do it is vitally important, and ultimately it'll allow us to simulate changes on that network. So what happens if I reroute traffic this way on this time period, or if I change the speed limit on the road? What will the outcomes be in terms of fatal or serious injuries avoided?
Mm-hmm. Okay. James, thanks a lot for the presentation, for answering these questions. We will now move to project SOTERIA with the Marina and Panos. They are here. They will turn on their cameras. Panos,
Hello,
Panos,
everyone. Can you hear me okay?
Yes, I must
Okay.
ask you, Panos, that's a very cool background. Is that one of the team's backgrounds, or is that
No,
really your office?
that's my actual office.
Nice, nice.
It's a real one.
How are you?
Okay.
Welcome.
I'm fine, thank you. Okay.
The floor is yours, or the screen, should I say?
I've shared my screen. I don't know if you can see it okay. Yes.
Yes, we can see it okay.
Okay. So I'll be presenting the SOTERIA project. For the SOTERIA, we sort of started the journey by sort of trying to understand exactly what was the expectations of the calls, and then try to sort of create our concept and our offering based on that. And of course, we've seen quite a few statistics about accidents and you know, the higher numbers of accidents, especially on involving vulnerable road users. So one of the sort of objectives, or one of the early sort of needs that to identify was the need to develop some solutions that will operate at planning level, but also in real time, that will somehow try to minimize the risks and try to sort of contribute to the target set by the EU regarding the 50% reduction of serious injuries and fatalities by 2030. We also identify the need to have solutions that can actually address a range of different VRUs. And of course, different types of VRUs have different requirements, they have different needs, they have different perceptions in terms of safety, and also they take different risks. You know, younger generation are more, let's say, risk prone in what they do on the road. So we try to sort of come up with different themes for the pilots of the project to be able to address these different requirements and needs. We also thought that and saw the need to be able to harness data. You know, we needed to understand a bit more about the accidents, the causes of accidents, but also, you know, there is a lot of new mobility services over the last few years, and of course, there's new types of micro vehicles as well. So there's a need to understand the demand for those services and try to sort of take this demand into consideration when we design new safety systems and solutions. And also, of course, we saw safety as a driver for promoting active traveling, and of course there's a lot of initiatives at the moment at the EU level to sort of, you know, increase the use of walking, bicycles, and all those sort of micro vehicles, of course, that are very environmentally friendly, but of course they have to be supported by the right safety systems. So as an aim, of course, we try to sort of put all these things together to come up with an offering that will sort of support the Commission's Vision Zero target. And in terms of the project itself, there's a consortium of 16 partners from 7 European countries. And the main idea is really to come up with different, let's say, services that will facilitate this safe traveling of VRUs. And of course, this includes a number of activities from try to understand the behavioral characteristics of different VRUs, involve VRUs and stakeholders in the safety domain as part of co-creation activities. So they are actually part of the design of the solutions. Also, so the need that also James mentioned earlier about some tools that can facilitate integration of simulation models and data-driven analytics as part of the design of these solutions. And there's two main areas of work as part of the SOTERIA. One of them is to protect the VRUs while they are actually traveling. And the second one is to try to, let's say, propose some solutions that will facilitate the safe integration of all these new micro vehicles into the traffic streams. So leading to the objectives of the project, the first objective, of course, is to sort of assemble the different living labs that will sort of facilitate these co-creation activities that I mentioned earlier. Try to extend existing simulation models to take into account a number of different safety indicators, and again try to sort of populate those with a number of data-driven analytics. Then try to develop a number of services that will facilitate safe traveling for the vulnerable road users, and also have some tools like nudging to sort of promote safe behaviors. Try to also develop solutions that will make VR use more visible to other traffic users or private cars, freight vehicle drivers, etc., and sort of raise the awareness of those VR use. I think this is very similar to the example you mentioned and the crash example you actually presented earlier as well, where the VRU had all the right equipment, but of course the driver of the vehicle wasn't paying attention, and of course that resulted to the crash. And also try our solutions in different urban contexts and different sort of social conditions through the pilots that we have designed, and as part of the outcome of the project also to provide some training courses to, let's say, educate the users based on the findings of the project and also the solutions that are going to be developed, but also provide some policy recommendations. So these sort of objectives were divided and used to construct the axis of the project, and I'm going to go into a lot of in a bit more detail for all of this later. But of course, the first one was the co-creation and social innovation living labs. Then there's an axis looking at the advanced accident analysis and sort of generate some intelligence from data, increasing the safety of vulnerable road users, facilitate the safe integration of micromobility services, and also demonstrate the solutions and try to augment their impact as well. So in terms of the co-creation and social innovation living labs, the plan is to introduce those into different areas, different cities in Europe, and use these as vehicles to facilitate three main activities. The first one is try to understand the behaviors of vulnerable road users, try to do some studies with different types of VRUs and try to develop a taxonomy of needs and behaviors. Then try to develop a modeling and simulation platform that will allow the assessment of different interventions before they're actually put in place. And also use these sort of findings from the analysis of the behaviors, but also the modeling and simulation tools to co-create solutions that then will be developed as part of the project and demonstrated in the different sites. Of course, we saw the need to be able to collect data from different sources, and as part of the project, we are hoping to develop a quite comprehensive mobility data space to sort of collect data about accidents. We saw a very important need to collect data about near misses. So there's a lot of data about accidents, but there isn't a lot of data about near misses. And of course, the idea is if we can actually understand what causes a near miss, we can maybe break the chain of activities that could potentially lead to an accident. So there's a lot of emphasis in our project on using some technologies to sort of detect near misses, but also use connected vehicle data to try to find accident hotspots where maybe vehicles decelerate very rapidly. Maybe there's some problem there. So there's a plethora, if you like, of data sources that we're going to try to integrate as part of the mobility data space, and that will sort of, let's say, support all the services that will be developed as part of the project. So at the lower level of our sort of data processing, we have we are creating a number of data analytics and AI tools to provide services like risk heat maps. So this will use historical and real-time data to, let's say, formulate high-resolution maps with safety-related parameterization. So this can be like on a dashboard where different sort of operators and different stakeholders can actually visualize those. We also have hoping to develop an advanced accident analysis module that will use both statistical and sort of more AI techniques like deep learning to try to understand causes of accidents and create an taxonomy for those causes, and also try to support all this with explainable AI to be able to make sure that the users understand the messages that we try to present to them about the accidents, try to understand the causes of the different accidents, and then hopefully maybe change the behavior or risky behaviors when necessary. And then we have these two main, let's say, pillars in the solutions that we're going to be developing. The first one is to increase the safety of the VRUs. And again, we have a set of solutions that will facilitate that. First one is a safe routing component that will basically direct users away from risks and potential accident hotspots. And these are talking about VRUs. Also have this safety-oriented proactivity and nudge engine. So try to, let's say, detect hazardous situation in advance and try to sort of nudge users away from that. And of course, this will also apply for not only VRUs, but also drivers of motorized vehicles as well. Try to sort of give them some sense of awareness when, for example, maybe they approach an intersection where is also approached by a cyclist, for example. So have this sort of concept of VRU localization detection and dissemination of these locations to other users of the network, and also have this some sort of dynamicity of how accidents or how locations may be, the risk level of different locations may change, because of course there's a static information, there is historical information about accidents at specific locations, but of course this may change dynamically based on the demand level on that particular location, based on activities that take place on that location, or even based on exogenous, let's say, factors like weather conditions, etc. So try to have some sort of a dynamic updating of the risks that could potentially lead to the accident. And on the other hand as well, we have a number of solutions that will facilitate the safe integration of micromobility. As part of that, we try to develop solutions that will actually predict the demand for those services and the locations that that demand may happen. So again, we can see those locations as potential accident hotspots, because of course, the more the utilization of those micro vehicles, the higher the chances of an accident. Also look at ways of predicting and recording the behavior of different VRUs, especially cyclists and e-scooters. And a major output of the project is the development of a micro vehicle sensory kit. We know there is a lot of work in terms of sensors on motorized vehicles, but I think there is currently there is a bit of a gap on how this can actually be used in micro vehicles to collect information about the let's say the user, but also to collect information about the surrounding of the micro vehicle as well. And of course, we're going to use the sensory key to facilitate this identification of near misses as well. And of course, there's another of additional components and systems that we will like to incorporate into that, but just for the purposes of the presentation, I'm going to move on to the pilots. We have 4 pilots and areas that we are going to try to sort of demonstrate the solutions that we're developing, and each of those pilots has a different theme. We have a pilot in Oxfordshire in the UK. The main objective of this pilot is to investigate the safe integration of micromobility to, let's say, the current mobility paradigms. The emphasis is to see how existing infrastructure for cyclists can also be used for other micro vehicles. We have a second living lab in Saxony in Germany, and this will be realized in different locations. The main theme for that is the younger generation, or Generation Z. So we'll try to see how the solutions we are developing can support let's say, teenagers and try to protect them while they are sort of traveling. Then we have the Living Lab in Madrid, in Spain. The main objective of this Living Lab is to see how these sort of new mobility services, especially shared mobility services, can be affected, and what kind of solutions we need to develop to sort of improve the safety for those solutions. The main SOTERIA outputs that will be demonstrated in Madrid is the predictive analytics in terms of the demand, but also different sort of solutions related to visualization of accident hotspots and how maybe fleet operators can actually know the locations of those hotspots and take specific actions. And the last Living Lab is actually in 2 locations in Greece. These are sort of smaller towns, and the idea here is to thoroughly test this micro vehicle sensory kit, and use this sensory key to collect, let's say, information about the users and also the vehicle, the micro vehicle, and use that as part of a predictive analytics for safety. So this is, let's say, the main sort of presentation for the SOTERIA project. We have 16 associated partners from industry. We have universities. We have 2 data providers, one for connected vehicles, one for shared mobility services. And of course, we have a number of public authorities as well as part of the consortium, who will also be responsible for facilitating the different activities at the different locations in the Living Labs. Some information about the project. The coordinators are Intrasoft. The University of Wolverhampton are acting as a scientific and technical manager. You can see here the website and some information about the funding. It's a 42-month project, and we started last November. And in this slide also, there's information about the social media outlets for the project, and if you need to contact us, you can use this QR code and email us any for anything that you'd like. And of course, if you want to participate in the Living Labs, this will run across all Europe, so feel free to do so. And this is the end of my presentation, and I'll be happy to answer any questions.
Thank you, Panos. Thank you very much. Can you stop sharing the screen so we can see you in a bigger format?
Yes, let me find how to
There
do
must
that.
be a way. Okay.
Okay.
Thanks a lot. So let's go to Niklas. Niklas, what questions have you fished from the Q&A pond?
Yeah, I think what would be nice to hear from you, Panos, if you could elaborate on some of the concepts. So what is the concept of near misses and why are they important? And then also the second question that I give to you directly, could you explain the concept of safety-centric public spaces? I think those are key frameworks in concepts that would be good so that everyone has an overview of what this is.
Yes,
Perfect.
of course. So
Thanks,
yeah, so near misses are basically incidents on the road network that do not result in an accident, but they're probably like very close to an accident. So I'm a cyclist myself, and of course I face this kind of near misses pretty much every day or so, and of course they can be caused for different reasons. So the idea here is to try to record those near misses, because there's a lot of information about accidents. The problem with accidents is that you may not have too many accidents in particular locations, so you don't know exactly what's happening, or you may have accidents or have a lot of accidents in other locations, but that could be because of specific characteristics of the infrastructure, and so on and so forth. So with the near misses, we can have much more information about dangerous situations, so, situations that haven't let's say evolved into accidents, but could potentially in the future evolve into such accidents. So the idea is to be able to sort of monitor and record those near misses, and that's one of the purposes where we're going to be using these different technologies, from video cameras and LiDAR sensors on micro vehicles, to be able to sort of, you know, record proximity of the bicycle to different obstacles all the time, and try to see where these sort of near, let's say, interactions of micro vehicles with other vehicles or other users may occur. And the second question, I believe, was about public spaces and safety.
Safety-centric public spaces.
Yes. What has happening at the moment is we have a lot of spaces that have been designed quite a few years ago, and they don't take into account requirements and needs of new mobility services. So, for example, we have cycleways or cycle motorways, and of course these have been designed for bicycles, but of course now have all these other, let's say, micro vehicles coming into the scene. We have electric scooters and all those micro vehicles are going to be sharing the same space. So we need to look at what's there now and see what implications we will have when these shared spaces, you know, will become more occupied, let's say, by different users. So the idea is to take all this into account and make sure and put designs in place that take into consideration all these different types of users, and make it, you know, safe-centric from the point of view that there is some sort of separation potentially between pedestrians and cyclists, or cyclists and e-scooter drivers, you know. So we try to sort of understand these sort of conflicts in the use of those shared spaces, and come up with some designs that hopefully will facilitate safe traveling in these spaces in the future.
Got it. Niklas, you have one final question. Easy question, huh?
Yeah, there are very two very basic questions in the Q&A section now. Do you have any connections outside the EU apart from the UK concerning similar activities? And then the second question would be, what type of participation in the living labs are possible? And are you still looking for some participants or some cooperation on the local level?
Brief answer, Panos.
Okay, so the first question, if I understood correctly, if we have any other sort of country outside the EU apart from the UK? No, it's just it's the UK, and the rest of the pilots are actually part of the EU member states, if you like. Mm-hmm. And the second question was, can you repeat that, Niklas?
The type of participation in the living labs, and can they still participate? What will you do, like a brief overview?
Yes, anyone can participate. So the living labs are open to any interest party. We have 4 main locations for the living labs, but we have a network of 8 cities as part of the project. And of course, the studies that we are planning to do for capturing behavior, capturing stakeholder needs, this will actually go beyond the living labs as well. So we welcome any registration on our website for people that would like to participate in the activities of what we call living labs, but it will be in the whole, let's say, EU area.
Panos, thanks a lot. Thanks a lot.
Okay,
let's move now to V4SAFETY with Olaf Optenkamp from TNO and Sanne van Gils from SWAB. And are you there?
Yes, we are there.
You can all see that Olaf is wearing one of those Teams background. Welcome. The floor is yours. Go ahead.
I'm trying to share my screen. Do you see my screen?
Everybody sees your screen.
Yeah.
Great.
Everybody sees your screen, Olaf. Only you don't.
Excellent.
Is it fixed now? Okay, go ahead.
Thanks, Pedro, for this kind introduction and for the inspirational previous presentations. My name is Olaf Optenkamp. I work for TNO, the Independent Research Institute in the Netherlands. And actually, TNO is coordinating the project V4SAFETY. And I'm today here with Sanne van Gils. She is the Communication and Dissemination Officer of V4SAFETY. And she works for SOF, at the Road Research Institute of the Netherlands. First of all, who is V4SAFETY? Here you see the logos of the participants in V4SAFETY, and you will recognize easily a huge bunch of the automotive industry dedicated to safety with their suppliers, and added to those partners are organizations that are dedicated to road safety research. Maybe a special focus on the University of Florence, who in this V4SAFETY project that does a lot with automotive, also looks to the infrastructure element thereof. And they are highly esteemed for that aspect. Oh, yeah, actually I've seen this trend before shown by Pedro. Just wanted to show why we are actually doing this type of project. We're facing the need for a decrease in road fatalities, actually also in severely injured on the road, and the last decade almost, it's becoming more and more difficult to achieve that. If you look in a little bit more detail to where or why road traffic fatalities in the EU occur, you see a lot, let's say, actually in the crashes, collisions, interactions with motorized vehicles like cars and lorries, with vulnerable users like pedestrians, cyclists, moped riders, and motorcyclists. Actually, this is the overall view on the interactions and road fatalities. If we look to urban, then it's becoming even more dominant that this column of car-related fatalities is very dominant. I will come back to that later, because that's part of where V4SAFETY actually is focusing on. Now, in the last years, a lot in the traffic system is changing. There are a lot of technologies being introduced. Among of these technologies is artificial intelligence. You also see an increased movement towards higher levels of automation in vehicles. And the result thereof is that the role of the human driver is changing. It actually evolves as a result of new transport modalities being introduced, various levels of automations being there, and even an increase of communication between infrastructure and road users and between road users. Now, to see the effect of all these type of changes on safety, there is a clear need for a safety assessment framework that's actually capable of dealing with these challenges and these fast developments. Of course, the introduction of such a safety assessment framework puts requirements to the users thereof, but of course also to the development, because in the end we want to make use of this safety assessment framework on a daily basis, which means that we need to have a reliable outcome of the safety performance of any type of system within a feasible testing effort. And that makes the need very large to do making use of virtual testing using computer simulations for that. Of course, if we set up such a safety assessment framework, it needs to conform with the regulations put out by the European Commission, also by the UNECE, as well as with international standards like ISO and SAE. And in the end, the safety assessment framework needs to be fair, comparable, and clear. And Mainly, it needs to give unambiguous results. Results must be easily understood, and they should be explainable to all the different levels where safety is important, up to the level, of course, of the citizens of the EU. Now, V4SAFETY is dedicated to set up that type of safety assessment framework and takes there the perspective from a vehicle, of course, because one of the main causes of fatalities and severely injured people on the road are these interactions with vehicles. Now, the safety assessment framework should be capable of dealing with a multitude of different type of solutions. I mention here in vehicle safety solutions, infrastructure solutions, and regulatory changes. So results from, for instance, regulations that evolve from policy introductions. And if we look to in-vehicle safety solutions, we just provide here several examples to show what we are thinking of. The examples we give here are not necessarily dealt all with in V4SAFETY, and on the other hand, there might be safety solutions in vehicles that we not mention here, but that we will take on board in our research. Well, for in-vehicle safety solutions, you can think of autonomous emergency braking, intelligent speed adaptation. A very large focus lately is on automated lane keeping systems for highway applications, driver nudging through the human-machine interface. We look to infrastructure solutions, for instance, speed bumps or differences in road layout that should lead to safer behavior on the road, or things like the color of the tarmac indicating there is a dedicated cyclist lane. And regulatory changes, you could think of speed limit regulations on helmet use, or allowances for vehicle at certain areas on the road. What are then the objectives of V4SAFETY? Well, as I already indicated, we are developing a predictive safety assessment framework, making use of computer simulations that is widely accepted and harmonized. That's what we strive for. This safety assessment framework makes use of simulation models, and we need to ensure that these models properly address the behavior of all the different traffic participants that are important in those simulations, which includes drivers, vehicle occupants, and of course, any type of vulnerable road user. As indicated in the previous slide, we address different types of safety solutions in vehicle, infrastructure, and regulatory. And we are going to demonstrate the framework for relevant use cases. We have identified use cases for ourselves, but of course, it's very likely, and we have already had our first discussions with SOTERIA and PHOEBE to see if use cases can be exchanged from these projects as well. Then in the translation of the results of the safety assessment framework, there needs to be a methodology that needs to be developed for projecting the benefits of the application of safety measures that has both, let's say, a location variable in projection from certain areas to all of the EU. It also has a time variable, because we need to do that for the coming years, including there the expected changes in the mobility system that will happen over the next years. So looking to what is the effect on performance of a certain system, keeping into account the changes in the mobility system that might occur. We look to different possible use cases from the possible interaction between road users, where you have here the the first road user, pedestrian, cyclist, power two-wheeler, passenger car, commercial vehicle that can come into conflict with another road user. So that's the domain we are looking at the behavior level, the regulatory level, the infrastructure and vehicle level, and we are focusing mainly on the right part of this figure, where we look to what can we do in the system, mainly at the part of the vehicles. So how can vehicles help to prevent collisions with other vehicles and specifically vulnerable road users? 4 use cases have already been identified in the project, where we look to the crossing passes of a passenger car and e-scooters. E-scooters drive fast and are very maneuverable, and it might be difficult for a driver to see the intention of the e-scooter and therefore might come into conflict with that e-scooter. We look to the possible conflict between pedestrians and cars. For instance, with a jaywalking pedestrian, it's very difficult for a car driver to distinguish a pedestrian that is crossing the street, for instance, crossing from between cars that are parked at the side of the road. And it's especially terrible if that is a playing kid, which is fast and small. Another use case is that between a bicyclist and a car or a truck, where a truck might take a right turn and the bicyclist might be in the blind spot of that vehicle, difficult to distinguish and difficult then also to prevent an accident. And the fourth use cases that we already identified is that between a car and a power two-wheeler, where the power two-wheeler continues on the straight road while the passenger car is making a left turn, having difficulty in judging the distance and the speed of that approaching a power two-wheeler. As said, these are just already identified use cases. We are in the process of looking where do we have the largest benefit to be made. There's a lot of expertise with the partners in the project, but we also have already established a large network. We have an advisory board of several organizations internationally, so also outside Europe. In Europe, it's Euro NCAP and the Joint Research Center of the European Commission, where we have also in the advisory board the Automobile Research Organization from Japan, the Technological University of Singapore, the Transportation Research Institute from the University of Michigan, the Virginia Tech Transportation Institute, and ASAM. ASAM is an automotive standardization institute dedicated to making sure that there are interfaces between different tools and different models are harmonized. We also establish contacts to the simulation tool providers that are here, and actually this bunch of tool providers have the largest market share. Doesn't mean that any additional partners that might be there and that provide tools for these type of simulations, that they are not very welcome, and we will be looking to extending this network throughout the project. Then we have also already bonds to some harmonization initiatives like the ISO working groups looking to road safety, and the peers harmonization group looking to harmonization of simulation tools. What's the outlook of V4SAFETY on the collaboration and the impact actually on the in Europe? Well, you already have seen that the 3 sister projects each have their own perspective, which is very valuable because we think that we cover the road safety domain quite well with those different perspectives. And we think that by doing that, we can significantly contribute to the road safety improvements now and, of course, in the future. From V4SAFETY perspective, we see the following impacts on the societal level: the accelerated introduction of relevant road safety measures, of course, with the intention to reduce human suffering due to traffic accidents, with a special focus on vulnerable users. From a scientific point of view, harmonized framework and principles with standards for reporting and documenting results to get a kind of more easy way to get an interpretation of what the performance of safety solutions are on the road. From a technological side, reliable studies that shorten the development and implementation cycles. Again, with the focus on improving traffic safety, traffic flow, and reducing then the cost of crashes, which then is also an economical impact, of course. This is us in the kickoff meeting in The Hague. We started October 1st last year. You see actually the contact data of the coordinators and the communication and dissemination officer. And here is, I would like to give you the floor for questions.
Thank you very much. Really interesting. Really interesting. Niklas, do we have questions?
Yeah,
Throw them at Olaf.
Yeah, we have a question from the Q&A section from Thierry Woolsgrove. I hope that's pronounced correctly.
Thierry Woolsgrove.
Oh, sorry. Okay. Vehicle regulations concerning intelligent speed adaptation will be reviewed in 2025 by the EU Commission, and other ADAS regulations will be reviewed in 27. Will the project be able to contribute to these reviews? I think that's a quite a long-term question and a difficult question, but maybe you have an answer on that.
Yeah, I think looking to the partners in the consortium, we certainly are. It's a topic that is already on our radar, and not only for the project, but actually for the partners in the consortium over the last years. Also with the introduction of intelligent speed assist by Euro NCAP. So for sure, we will be looking into that domain as well. And consequently provide input to those regulations. Yeah.
Yeah, maybe also a more wider question. As cars become more and more autonomous, what level of responsibility can we reasonably expect of their drivers? I mean, of course, these things like responsibility just cannot be given to the machine. But yeah, how can also scientists harvest these opportunities of these more and more autonomous and hopefully more and more intelligent machines?
Yeah, actually, we very much look there to the SAE levels of automation, where we start from level 0, where there's no automation at all, and everything is being covered by the driver, up to a level 5 type of system, where there's no active involvement of the driver, and these phases in between. Well, having level 5 a little bit on the background for the moment, because that will really take still a long time to achieve that. There's a lot of discussion ongoing on the levels 2, 3, and 4, and actually the ideas on driver responsibility are actually changing. I think that in the past with automation, we were thinking that if the vehicle could take over the complete responsibility, that we wouldn't have to focus on the human driver anymore. But we know that in this mixed traffic with different levels of automation on the road for the coming, I would expect, decades, the role of the driver is very important. And that means that also human factors research is increasingly important to make things work in the vehicle. Though the vehicle is capable of supporting and even taking over several tasks of the driver, we do need to understand very well how mode confusion works, how transition of control works, both ways around, and that's not something that's easily done. Actually, what we also think is that the V4SAFETY safety assessment framework will help to get an understanding of that, but we also will need human factors research to be capable to have that understanding of how people respond in vehicles. And yeah, the difficulty there is that it's not just one driver that always behaves in the same way. I mean, it's our mood, it's our temper, it's even our culture that has an influence on how we respond to a certain situation at a certain moment of time in the day. And dealing with that, that's one of the most difficult parts that we need to cover.
Niklas, time for one more question.
Okay, I would like to wrap it up with a very short and easy questions. We have heard a lot from vulnerable road users, but not only in your project V4SAFETY, but also in all the other projects. So how is the participation process with the vulnerable road users? How are you engaging with them, and what are the input opportunities from their side?
Yeah, well, we from V4SAFETY part, we take let's say the connections to other projects and programs that deal with vulnerable road users. In a way, for the safety assessment framework, it's important to have a notion on what are the typical behaviors of vulnerable road users out there, to which in each of the circumstances a vehicle needs to respond appropriately. So that will be the involvement of the different projects and programs throughout Europe, but even beyond, looking to our network to include those results of those researches into our models and in our framework.
Okay, Sane, if I understood correctly, Olaf was actively encouraging solutions providers to step forward and get in touch with your project. Did I understand correctly?
So, sorry, I'm not sure if I'm getting your question correctly, but
Olaf was encouraging, Olaf was actively encouraging solutions providers to come forward and to contact your project.
Yeah, definitely, definitely.
And they should contact you.
They can, yes.
Okay.
My contact info is in the mail, is in the presentation.
Okay, so thanks a lot, Olaf and Sane. Great having you here. Before we go, let me just give the screen or the floor and screen again to my dear colleague Niklas, who has some useful information. Thanks a lot. Niklas, take it away.
I hope you can see my screen. Should be fine, right?
Yes, sir.
So
yep.
I would like to wrap it up and to talk a little bit about what can you expect from us and how can you engage with us. First of all, I would like to thank everyone who participated today. Not only the participants, we had around 60 people in the audience, but also the panelists, of course, which delivered some very interesting content. But what will happen now? So the idea of the PHOEBE project and the two other projects, V4SAFETY and our colleagues from SOTERIA, basically, we want to have annual webinars because we want to to have to use the opportunity that road safety is basically in all of our DNA and all of our main topic basically, and we want to also participate in different congresses. So we have applied for the ITS Europe Congress. PHOEBE and the others will probably be for sure at our POLIS conference that we are organizing, and during other annual events you will also find us in the future. As we said, we just started, and we would like to keep in touch with you, and we suggest that you also subscribe to our newsletters. The PHOEBE one for sure will come out in April, and then there will also be other updates that you can find on the other home pages. So I really hope that we would stay connected, and this can be done by reaching out to us either by the homepage and the social media, and all the links are below. The problem is at the moment the PHOEBE project homepage is not yet live, but you can reach everyone else on their homepages and also on the social media. And I give you some time now to scan the QR codes. Also, this entire presentation, the recording and the project presentations will be uploaded on PHOEBE, but also the other project pages, and we try to cooperate a little bit more. And this is just basically the beginning, and we are even very pleasantly surprised that we already have so many participants, even though we don't even have anything concrete as a result to present. But this will of course come in the next couple of months. So from our side, we would like to thank you, and I will give the floor back to my colleague Pedro.
That's it. Just to thank everybody for your time, for your presence. It was a pleasure once again to thank our speakers, Panos, Marina, Olaf, James, Sane, and Niklas, of course, for managing the questions. We look forward to seeing you again in future events by PHOEBE and or SOTERIA and or V4SAFETY. Have a wonderful day, everybody. Bye-bye.
Thank you, Pedro.